Designers often create works-like prototypes with moving parts to explore the mechanical functionality of a product. Creating such prototypes with CAD tools requires significant expertise. Users must carefully specify the part dimensions and joint parameters to ensure a working interference-free model. We present a system that allows users to create works-like prototypes by specifying high-level functional properties of the design. The user starts by creating a rough 3D model of the object with parts represented as cuboids, and specifying what types of joints connect various parts. In general, the part and joint parameters of this rough model will not result in a working instantiation of the design. Here, the double pivot joints do not provide enough clearance for the parts to move without colliding, and when the bed is folded, the head and footboard do not line up with the platform. To produce a working model, the user indicates the relevant functional relationships between parts. For example, the head and footboard should cover the platform when folded. Based on these relationships, the system automatically updates the part dimensions and joint parameters to generate a 3D model that can be fabricated to produce a works-like prototype of the design. Our system supports 4 types of functional relationships: cover, fit inside, support, and flush. We provide semi-automated tools that allow users to quickly specify these relationships. To specify a cover relationship, the user selects both the covering and covered faces and directly manipulates the relevant parts into the covered configuration. The system updates the part geometry to ensure the relationship holds. To specify a fit inside relationship, the user selects the inner and outer parts. The system updates the part dimensions so that the inner parts fit inside the outer. To specify a support relationship, the user selects the supported and supporting parts. The system updates part dimensions to ensure that the supporting and supported faces overlap in the same plane. To specify a flush relationship, the user selects 2 faces that should be flush with one another. Again, the system updates the part dimensions appropriately. Once the functional relationships are specified, the user can modify part dimensions to explore design variations. As we widen the cabinet, the doors automatically get longer so that they still cover the front. Once we specify that the doors should also fit inside, the depth of the cabinet changes with the width. Finally, if we add a cover relationship for the lid, then its dimensions change with the cabinet as well. The system also allows users to easily add and remove parts while maintaining a valid design. In this jewelry box model, the lids of all the compartments hinge open and then slide to fit inside the box. If we remove one of the compartments, the remaining compartments grow to cover the empty space, and the box gets deeper to account for the larger lids. Here, we remove one more compartment, and we change this lower compartment to be a drawer that slides downwards. The box gets shallower again to accommodate the remaining hinged lid on top. We have used our system to create works-like prototypes for a variety of designs, including articulated devices, appliances, and furniture.